folks. Welcome to another Cosmology segment here. And we're going to hopefully not melt anybody's brain too heavily on this one. But we're going to start out here on the web whiteboard and talk a little bit about where you are, where you're going, and how things work, how things don't apparently work within our galaxy in this little cosmology segment. And by the way, if you haven't watched our cosmology segment, toroids versus poloids, toroidal fields versus poloidal fields, I suggest you check it out. Now let's start out where we are in the Milky Way. The sun is traveling at a path like this with respect to the galactic core. Some kind of an angle like that is the route the sun is taking. And here's an image of the local environment here, which we call the local chimney. This is the area of, you could say, dust and gas, etc., around the sun, and this is showing you the sun's motion here to the upper right with the galactic center at the right. So it is a different perspective, but so just to give you some idea, if you look up in the night sky, you look at Sirius, the sun is moving away from Sirius. And it's at about like maybe a 70-degree angle, nearly perpendicular to the galactic center. If we look at the Milky Way galaxy, now of course we can't see the Milky Way galaxy from this kind of a perspective here. This is just an artist's rendition of what it may look like with the spiral arms and so on. Many people believe the Milky Way to be a barred spiral galaxy. So some kind of a rectangular feature in the middle, according to some. Some even think a nested bar. In any case, the view that we see is similar to this. Cygnus is over here. That's the Cygnus arm right there. And so we're looking across a giant torus. That is the Milky Way galaxy. When we look at the center, there's an area of uncertainty over here where we have no idea what is behind the core because there's simply too much stuff in between us and it, as well as magnetic fields. And now just to go back to the local chimney here for a moment, part of the reason that we have this YouTube channel is to study the sun in super great depth and attempt to figure out how the sun behaves the way it does. And is it just a matter of gravity and inertia that are determining the sun's motion, or is there more to it than that? Well, let's get into it. I apologize for the guerrilla techniques used to make this one, as we are using a web whiteboard here. We'll make it available for people to mess with later. But for now, let's talk about what the sun does. One of the things that we know that the sun does is emit protons. And we've made a custom GIF animation here using helioviewer.org to show you the South Pole coronal hole. At both poles of the sun, there are enduring coronal holes that are undoubtedly blasting out streams of protons all the time. You could call these cosmic rays. As we know, when a coronal hole faces the Earth, we see solar wind speeds go up to as high as around 1,200 kilometers per second. And so it's quite obvious that there is, it's beyond reasonable to assume that there are proton beams coming out of both poles. And what do we know about when coronal hole wind streams hit the Earth or hit the magnetosphere? Well, we know that they cause an uptick in electrons afterwards, indicating that these things come out like a pulse. So you've got, here's a proton, that's a helium nucleus, I should say. Let me make it a little bigger. Here's a helium nucleus. It's traveling at, say, 600 kilometers per second, coming out of the coronal hole. What that's going to do, if there are free electrons and the sun does indeed seem to have free electrons. This is going to peel electrons off as they're going to want to follow this. So you've got this much more tiny particle here. In fact, let's make it blue. Just so you understand that that's an electron. This is eventually going to be following this proton. And this is what we see out of the solar wind. When we see an increase in the solar wind density and velocity, a few days later, we'll see an increase in the electron flux. Now, let's talk about what cosmic rays are made of. By the way, we included this image here. This is an image of the sun from above. As you can see, there is a enduring coronal hole there, and fortunately, the European Space Agency is less than a week from the possibility of launching their Orbiter 2 mission, so we'll get better views and data on that. But that aside, cosmic rays are 99% nuclei, atoms of regular old atoms that you see on the periodic chart, and 90% of those are hydrogen nuclei. We've included a diagram of what a particle stream looks like when it hits the atmosphere of the Earth, as it breaks into all kinds of different secondary particles, forces, waves, whatever you want to call them. But anyway, 90% of the solar wind is protons. 1% is electrons, and we always see this increase in the electron flux following an increase in the proton flux. So it's fairly reasonable to believe that there is a constant stream of protons coming out of here and a pulsed stream of electrons that is constantly interacting with it. So you would think you'd have some kind of a situation like this. You've got protons and electrons constantly coming out of the sun, and that is a direct effect of the sun's magnetic fields. But I digress. Next, we've got on the whiteboard here, we've got an image of a blazar shown here. And now a blazar is a special perspective situation where the poloidal jet is coming directly out and facing directly at the Earth. Now this creates particle showers in space as well as it does on Earth, and the magnetic fields associated with the emissions of these sorts of things completely affects the way the light behaves. Scrolling down, we have an image here of the poloidal jet, or you could call it a Z-field jet. So some folks call them relativistic jets. This is the famous radio source, which some folks think is a black hole, known as M87. And notice the pulsed appearance of this. You've got a dense spot here. You've got a dense spot here. You've got a dense spot here. And in between those areas, you've likely got an electron stream. And this is what causes these things to accelerate and interact with each other. It also causes this entire area to be distorted. In other words, if you were looking at it from this location and you were looking in this direction, it would look completely different than it does from the direction we're looking at it. As you are inside of this jet, so there's a stream of protons and undoubtedly a pulsed stream of electrons in between. And this is part of what causes these objects to look so distorted. But the point is, folks, there is physical matter, primarily hydrogen nuclei, but also other heavy elements. We're talking about things that are heavier than an electron here. Hydrogen nuclei, a good percentage of it are helium nuclei, otherwise known as alpha particles, whatever you want to call them. And they're all traveling at hundreds of thousands of miles per hour. We've also included yet another image here of the toroid versus the poloid. And what we're looking at here is toroidal motion. The toroid shown in orange, toroidal motion shown in blue, poloidal motion shown in red. These things are completely different systems, and while they are related, they behave totally differently in an astrophysical fashion. Now, let's consider this image here. This is just a GIF animation of the solar wind with a rotating Earth in the background. Let's consider the sun's heliopause for a moment. Now again, this is an image of if you could see the protons coming out of the sun, bouncing off the magnetosphere, and then getting funneled in and out at the poles. You can see the Earth's poloidal fields shown here. Now, let's consider the possibility of what this situation would be like if we considered the sun in this location. So, obviously, you would think Sirius would be in this direction, and the sun's motion would obviously be in the opposite direction out this way. What does that mean about the shape of the heliosphere, the shape of the heliopause, and where do these poloidal field lines go? As there are undoubtedly Birkeland currents or series of Birkeland currents coming like this out of both poles of the sun. The real question is this: does one of these point toward Sirius and the other one point toward the sun of the mode of the sun's travel? Do they both point to the same location where one curves around and goes to the same place as the other one? Well, the long and short of it is we don't know the answer. And no matter how electric universe or non-electric universe you might be, this is an issue, as we cannot see what is happening in those areas, and let's just hope that the ESA's Orbiter 2 mission helps shed some light. Let's talk about one more thing real quick while we're on the whiteboard. Let's consider briefly the idea, and it's a fairly sound idea, that the sun is actually made of liquid metallic hydrogen. If it were made of liquid metallic hydrogen, it would consist of these layers of lattices, which look a lot like graphite. It explains why the sun appears to be dark at the layer of the photosphere, emits like a metal, the magnetic structure. It even explains coronal holes. So what would happen here is when you get enough dust around the outside of the sun, these liquid metallic lattice layers are going to have free electrons with which to perform chemical reactions with the dust on the outside, out at the chromosphere and out in the corona. When you take enough electrons away, this lattice breaks apart and the compressed gas in between the layers of lattice escapes, blasting material out into space, taking some of the liquid metallic hydrogen with it, and that completely explains how coronal holes work, folks. So please consider it when you're looking at models as to how the sun actually works, because the sun is indeed the Rosetta Stone of cosmology. The idea that we know the masses of other stars and other galaxies and all this sort of nonsense is all based on estimates of the sun's mass, based on the idea that it has a nuclear fusion dynamo inside of it. And when you prop up that many assumptions with that much bad science, you don't see the correct emission lines. I mean, it's clear that the sun is not made of a gaseous plasma. If it were, it would not be able to do what it does in terms of its magnetic fields, its emission lines, and at least 38 other things. Let's talk about some of the resources used in this whiteboard. Here are some of the sources. We used information from Wikipedia about Sagittarius A star. And by the way, let's go back to the galaxy map for one more quick second. And here's the view of the Milky Way. And the thing I'd like to note here is that Sagittarius A star is not emitting jets in this fashion. That is not the way the magnetic fields appear to be oriented. Sagittarius A star is on its side. It's at some kind of a funky angle like this. And I believe it interacts with the sun in an indirect fashion through the spiral arms, not directly. And this is why certain YouTube channels are incorrect about the way that a galactic superwave would propagate. As in, if Sagittarius A star suddenly had 3 or 4 of the giant supermassive blue stars that are orbiting it suddenly just all collide at the same time, the galactic superwave would propagate to the sun via the spiral arms, not through all of the empty space and blocking dust in between the center of the Milky Way galaxy and where we're located, in my opinion. Now, of course, it's obviously up for conjecture, but looking at the structure of things and the way poloidal fields versus toroidal fields operate, the violent activity happens in the poloidal fields, and the calm activity, such as life on Earth, happens in the toroid fields. And it's super important to understand the difference, as one acts like a rifle and the other one acts like a little foggy rainstorm. We've got other information here about the orientation of Sagittarius A star. Here's a fairly recent paper about the magnetic fields at the galactic core, and you can see how jumbled up they are in there. The Milky Way galaxy is not just simply a fractal of the solar system. It's a lot more complicated than that, folks. We've left links to all of these things. Here's an article about more measurements of the magnetic fields and the way they operate, as well as synchrotron radiation and some other stuff detected around these areas. So have a read on that if you like also. We've also included the paper that's cited about the resolution of the magnetic field structure around the galactic core. So that's all in there. The reference to where we got our numbers on cosmic rays, it's fairly agreed that cosmic rays are 90% hydrogen nuclei, but we left links to the Wikipedia page also, and there's lots of other sources to look at on the web for that as well. Here is the soft and hard components of cosmic rays article from Physics Open Lab. You can read all about that if you like. And let's get on to some less complicated things. Hopefully your brain didn't melt during that last little section there. Let's move on to something that most people comprehend, where things are in the solar system. As Venus and Mercury swing around, there's where things will be in 1 week, and hopefully the ESA's Solar Orbiter 2 will already be on the way to the sun by then. Let's cross our fingers. Here's what's going on above my head, despite it being light out. We usually make videos when it's dark out. And don't worry, folks, it's going to be changing soon. The whole operation has all kinds of different stuff going on. There's where things are at 8:30, another cosmic pileup happening as Mars and Jupiter and Saturn and the Sun and Mercury are all above the horizon at the same time. Let's look at a transient at the Neil Gorell Swift Observatory, my personal favorite. It's Cygnus X3, otherwise known as the star Deneb, Alpha Cygni, the brightest star in the constellation Cygnus. Also the most intrinsically bright object that we can see in the entire Milky Way galaxy. As this thing is kind of like a blazar, it's a high-mass X-ray binary down which we're looking the jet. We're looking directly down the jet of Cygnus X3. It is an obvious point source of cosmic ray flux. There is obviously some sort of a molecular connection, a protonic connection, complete with electron bridges in between one of the poles of Cygnus X3 and the Earth, and most likely also the Sun. And we'll be possibly writing a paper about this one this year. I would note also that when this thing gets into a quiescent state, that is always how it works. It has a 4.8-hour periodicity and some crazy tidal forces going on. If you read about how this thing orbits, it is absolutely out of control. And it is obviously 2 distinct objects if you read the papers about it. And you see it's in an ultra-quiescent state right now. You see here's the 0 line. But historically, the 0 line is way down here. And This thing is just ready to pop back off again. We're hoping we see some new science about it when it does. It's not an if, it's a when. Let's talk about arrogance in cosmology. Big Bang astronomers think that they know what happened in the universe's first 10 microseconds. So we've left links to this article if you'd like to lose some IQ points reading about this quark, gluon, plasma, and so on. And yeah, one other thing about cosmic rays before I forget. Just for all you people who've never taken a physics class and you're very scared of the Large Hadron Collider, let's talk about the most high energy cosmic rays ever observed, right? Well, they turn out to be 40 million times the energy of the particles accelerated by the Large Hadron Collider. If you think that the Large Hadron Collider is producing sunspots, just take a physics class. Please just take one physics class and then perhaps leave a comment after that, assuming you don't receive a D or lower in the class. And another article showing up today about the Daniel Inouye telescope, and it's producing the most detailed images of the solar surface ever measured through sheer size, as it's 4.24 meters. Did you know that they're building a 39.3 meter one in Chile right now? It's gonna be amazing. We've left links to the Extreme Tech article below the video. Let's talk about frame shifting and the Faraday effect. Well, there are articles all over the place talking about frame shifting. Oh no, not the frame shifting. Well, it turns out when we look at certain objects that have other massive objects orbiting them, and undoubtedly a massive disk of plasma in between them that's being skewed all over the place, blocking certain magnetic fields and accelerating other ones, at least accelerating the electrons. Well, once again, they're claiming that relativity was proven correct. I don't believe it. I think it's nonsense. I think the idea that space-time is distorted versus just simply the Faraday effect explaining all of this is total nonsense. But we've left links to the article on Universe Today if you'd like to read all about the frame shifting around this, I believe it's a neutron star / white dwarf system. And yeah, let's just move on to the Faraday effect. Please read about it. Faraday effect is the way light is affected in a magnetic environment. And I just like to remind everybody that space is not empty, and we don't need all these magical things to explain the things we observe. If you enjoy the content, please press like and subscribe on YouTube, as we've got hundreds and hundreds of daily space weather videos, not to mention other things about other things, such as cosmology segments, and even things like some movie reviews and stuff. By the way, check out Sky Scholar's channel. Congratulations on your approach to 20,000 subscribers there, Dr. Robitaille. Hit me up in the email. And we're looking to ask you some interesting cosmology questions. I don't know if you've been to smAsho.com/forum yet, but one of the sections there has just been amended to include another article in the full text about liquid metallic hydrogen solar models, as they explain more of the observed phenomenon on the sun than any other theories as to what the sun is made of. So have a read, and thanks everybody for signing up for the smAshomash.com/forum. It's been a wild success, and it's not even a month old. We've also placed the GIF animation that we used on the whiteboard on the forum, and you don't even have to log in for that, folks. We'll leave links below the video. Check it out if you want to download that GIF. Perhaps make it your desktop background or something. Next, I'd like to thank our patrons for being assistant and indeed associate producers of the show. Please consider becoming a patron, as we've got a lot of things to do in 2020, and we need a lot more funding to accomplish those things, such as filing our nonprofit paperwork this month. Thanks, Smash Team, for tuning in, and check out some bonus features. And first, we're looking at the last few hours here of sunspot 2757 as it sets over the western limb. There's the intensitygram. There's the colorized magnetogram. And it looks like it might have gained a little bit of complexity there. Here's the gorgeous 171 angstroms view of sunspot 2757 as it sets. And last but not least, we've got the speedy 131 angstroms view as sunspot 2757 begins to set over the western limb. We are out. We hope you enjoyed the cosmology segment, folks. Please don't forget to press like and subscribe on YouTube. Check us out on our other social media. Don't forget to check out smAshomash.org and smAshomash.com/forum. And we'll be seeing you soon. Stare at that sun.